Hi, I'm Catherine Plaisant.
And I'm Charlie.
We are from the University of Maryland at College Park. Computerized patient record systems are bringing to the physicians large amount of information about their patients. Our contribution to this area is a general visualization interface called LifeLines. It provides a visual overview and facilitates the navigation and analysis of clinical patient records. An intuitive approach to visualizing histories is to use graphical time series. This metaphor has been used by others. For example, the work of Pausner and Tufte, Cousins and Kahn, or the Telemed project. In '97, we started a collaboration with IBM Research to build a web prototype of LifeLines for computerized patient records. Our basis for modeling the record is an information system at Kaiser Permanente, Colorado, and we are now starting to use real clinical data. The medical record is summarized as a set of lines and events on a zoomable timeline. The current date is mid-February. This data spans about 6 months. Aspects of the records are grouped in facets: problems, allergies, diagnosis, labs, imaging, medications, etc. Problems are shown as lines. When a problem becomes inactive, the line stops. Here the patient quit smoking. Color can be used to indicate severity or type. The severe headache and seizure problems are red because their status was marked as alert. Severe allergies are red as well. Similar diagnoses are grouped on a line. The migraine line shows all dates where a migraine diagnosis was rendered. 2 lab results are shown. One stands out in red since its status was abnormal. Drug class has been used to group medications, with each mark representing a prescription date. The first glance at the lifeline tells that this patient has been in the office about every 2 weeks. It shows a series of concurrent problems and multiple medications. Correlation and its absence can be sought by scanning vertically and horizontally. For instance, it is suspicious that the constipation was closely preceded by a meperidine injection, or after noticing that the Dilantin prescription has been continued, one can assess how long ago the last blood level check has been done and decide if it is indicated at this time. When more data attributes are available, LifeLines can make better use of display attributes such as color or thickness. For example, for those drugs, if the approximate refill request dates can be calculated, it becomes possible to draw lines representing the dispense cycle and see when refills are being requested too soon or too late, using red to highlight possible overuse or underuse. Several means of interaction allow users to explore the record. I can zoom in and out or pan with a slider at the bottom. I can collapse facets to compact the record on the vertical axis, but the silhouette of each facet is still preserved. And red events are still visible and selectable. The labels can be seen at the top as the cursor passes over the events. Another way to deal with large records is to allow summarization of the events. Our data architecture allows a set of events to be recursively aggregated and replaced with summary events. For example, this series of atenolol and propanolol can be aggregated as beta blockers as we zoom out. In a different record, this series of label, flu, bronchitis, pneumonia, are summarized by pneumonia when I zoom out. Next, relationships can be highlighted. For example, a search can be performed on the entire record, highlighting all parts of the record that match the query. Here, a simple text search for migraine highlights all the drugs whose indication was migraine, or complaints explained by the diagnosis migraine, etc. The silhouette of the diagnosis facet still makes it clear that many visits were related to the migraine. But maybe the most important interaction is the access to details. All events visible on the display form a giant menu. A double click on any event, for example the sonogram event, will bring a picture or a report. To review the pneumonia, I could just click on the X-rays or the EKG.
Finally, a crucial aspect of the interface is the possibility for application managers and end users to customize the layout and display attributes of LifeLines. The patient data is stored in a database. A control panel allows users to map data attributes such as result to display attributes such as color. This phase generates runtime data used by the Java applet, but there are still many possible ways to lay out this data. While the x-axis values are fixed, events can be placed more freely in the vertical space. Choosing a compact layout option leads to a smaller, denser display that minimizes the need for scrolling, but the grouping of events horizontally may become less meaningful and less labels can be shown. A chronologically ordered layout helps to reveal events in the order they happened, but has a low data-to-ink ratio and requires more scrolling. Another option is to group events by their labels. That's what we used in the first example. These layout algorithms can be applied dynamically as we zoom. We also provide customizations for search, summarization, and label placement, and are now studying their impact on the usefulness of the display.
We have designed and implemented LifeLines and have begun testing it on real clinical data. Using the familiar metaphor of timelines, LifeLine takes advantage of our ability to visually analyze information-abundant displays and facilitates access to the details in the record. We believe that such an interface can have a significant influence on the usability and overall impact of electronic medical records.